Hello everyone, this is Vishnu, and the topic for analog digital electronic subject is on FPGA versus GPUs in data centers. So let's get started. So first of all, what exactly is an FPGA? So FPGA is nothing but a field programmable gate arrays, uh, which is an integrated circuit with complete access to the hardware, where you can use where you can program, where the end user can program his very own, program the whole FPGA. So it's completely on the end user's side, what to do. The user can decide whether to allocate this much of memory or this much of processing power to these minor tasks, or at these temperatures, allocating or providing complete access to the hardware at that particular temperatures, or doesn't matter, whatever application or whatever, whichever feature the end user wants, he can implement with these FPGAs. So as GPUs or ASIC, the circuitry inside an FPGA chip is not hard edge. It means that it's not hard programmed, or it's not even programmed, so it can be reprogrammed as needed by the end user for their needs. So moving on, what is the GPU? So GPUs are commonly known as graphical processing units. These are pre-programmed and are not as flexible as FPGAs. GPUs are now can be programmed up to a sort, but not completely, but they are not as flexible as FPGAs. So GPUs are designed for parallel processing, which are now the NVIDIA and AMD are calling it as CUDA cores. So designed for parallel processing, and they're used for video rendering or frame rendering. Frame rendering in the sense it's for games. So the faster it renders a frame, the more FPS we can get. FPS is nothing but frames per second. So GPUs are also used for AI applications, where deep learning consists of complete matrix calculations, and machine learning algorithms consists of, uh, they are based on formulas and methods, but deep learning applications are completely based on matrix calculations and completely based on matrices. So moving on, inside an FPGA. So a basic FPGA architecture consists of thousands of fundamental elements called con- configurable logic blocks, which are surrounded by a system of programmable interconnections called a fabric that routes signals between CLBs. So CLBs are nothing but configurable logic blocks. So input-output blocks interface with FPGA and external devices. So these configurable logic blocks can be used by the user, whether what to do and what not. What to do and what not to, and these are surrounded by a system of programmable interconnections. So as said earlier, these logic blocks can be interconnected, uh, so interfaced, uh, as the users wish, and and these interfaces are known to be as fabrics in FPGAs. So which will route the signals between the configurable logic blocks. So input output blocks interfaces between um, FPGA and external devices. Let's say if in the case of GPUs we got PCI Express slots, which is an input output. We can consider it as one of them. because the data from the hard drive or from the RAM is sent to the VRAM, which is video RAM for GPUs, and then the from that VRAM, the data will be sent to the GPU, and the processed information will be sent back to the motherboard, and it will send it to the CPU or something, and CPU, or it may directly output it on the device or the output device. So this is how input output blocks interface between FPGAs and external devices in the case of FPGAs. So inside a GPU, it consists of PI connector, um, which is used to connect interface with the motherboard, a graphic processor, and a video memory, which holds the data that needs to be processed by the graphics processor. So latest GPUs does come with CUDA cores, which are whose sole purpose is to enable parallel processing and hence reduce the of complex time of completion of a specific task. So FPGAs versus GPUs. Data center is a place where a number of from thousands to millions per second of requests will be carried out. If we are using, let's say, Facebook, which is uh, whose servers need to be so quick so that they can transfer information and send data to the clients. So data centers are nothing but the centers where data will be present, which can also be called as clouds, which are nothing but the server farms. So those are nothing but the data centers, and these server farms consist of the data. And with the help of client server operations, a client can retrieve or send data to the servers. So these, uh, so millions, thousands or millions of operations needs to be performed, or thousands or millions of requests will be sent to these data centers. So from all over the world, it depends on the server's flexibility or the company. Uh, it depends on the company, where the company exists, and all other things. Let's say Facebook. A few countries won't. I mean, doesn't have Facebook, maybe, like that, and a few countries might not have complete access to the Google servers. Might be they might be lacking out with a few features what Google provides in other countries. So like that, it depends on the data center where it is, and how many requests it does get, and requests it needs to send. So that's very highly uh, in demand tasks. So FPGAs can be so promising than GPUs, because FPGAs can be completely reprogrammable and reconfigurable according to the needs. So, well, FPGAs does fail in very big batch files. So GPUs come into play for very small files and small data. I mean, less data. FPGAs really shine, and these things are mainly power efficient rather than the GPUs, where GPUs are very hungry and FPGAs are not. And these FPGAs does enable acceleration of applications running on the server. Like basically, servers do have two CPUs for them. Well, nothing like the normal consumer grade computers. Only one CPU is will be provided, but for servers, there are going to be two CPUs at least, or at most. Uh, so these FPGAs will also contribute in taking a bit of load from those CPUs and processing the information, which will lead to acceleration of the application. So, and FPGAs can also communicate directly with the client. Actually, this is done by the CPUs, and but FPGAs can also do that. Well, it depends on how the end user has configured the FPGA. So FPGAs are known to be power efficient than GPUs, as said before. And thank you for everyone.